Hi guys, so today we're going to be doing a Bifrost graph tutorial, and specifically we're going to be looking at NPM. We're going to be creating something a little bit like this, where we have two NPM sources that mix together, they collide with each other, and they are two different colours. Hasn't been, should I say, the easiest thing to work out. I've relied heavily on the Bifrost forum, the Bifrost beta forum that I'm part of, and quite a few people in there have been really helpful, and we've managed to together get to this point of doing something like this. My version is a simplified version. There are some slightly more complicated versions, but I'm just going to show you my workflow, how I kind of came to this, and we'll just want to share that with you guys so the community can start to play around with it themselves and see where we can get. The further you guys start playing around with this, the further we can sort of push all these effects on. And what really drove me to this is to do this kind of thing is I've seen some Cinema 4D type. I'll just try and bring one up here. Examples which I thought were really nice. I think it was using Nparticles. So it was
why don't we have some fun
this guy and doing these kind of things, which was, I just thought, wow, this is really nice. So yeah, Nparticles and Octane, and I was like, well, why can't Bifrost do this? And obviously NPM will allow us to do that. These simulations, forget about doing anything like this in Nparticles, or any other standard sort of particles within Maya. The simulation runs incredibly fast for what it is. We're filling up full volumes here. We've got some crazy emission going on, which is really different. I'll show you how to do all that. So we're going to get started. I'm going to start completely from scratch, and we're just going to go through this together. I've got a black screen. It just enables me to see particles and whatnot a little bit better. So I'm just going to start with a torus quickly. I'm just going to get the graph up. I don't want to make this too big because obviously we're working in a simulation which relies heavily on scene scale, and we don't want to create something that's like 700 meters or the size of a building, because we're just going to be simulating forever. So torus, I'm going to create two spheres. I'm just going to have a sphere over here, and I'm going to have a sphere over here. And for now, I'm just going to assign an Arnold shader to this torus, and I'm just going to stick a little bit of transparency on it just so that we can see through it. Let's get the outliner open and dock that in here. No, in here, not on my other screen. Outliner, right, so we've got a torus, which is great, and two spheres, and well, that is it really. I might just shrink those spheres down a little bit. So they are sat inside there, are they not? Yeah, they are. Alright, so let's get rid of the grid. Display grid, two spheres, boom. Right, so here we go into Bifrost. Right, so let's move the output out of the way, and I'm just going to drag in my sphere 2, my sphere 1, and the torus for the collisions. Cool, so let's start bringing in some NPM stuff. So I'm going to bring in NPM solver settings. I'm going to bring in the NPM simulate NPM, and I'm going to bring in an NPM source. So the first one I'm going to bring in is sand. The second one I'm going to bring in, yes, we can mix different types of NPM, so I'm going to bring in a snow as well, and let's just make this bigger. I'm going to pause the graph, so control plus sign and the dot or the period, whatever you want to call it, and you can also do that in the graph execution here, and that just stops everything executing while we're putting all this together. So sphere, let's get simulate NPM down here, let's get the solver settings around here somewhere. I'm going to have my snow up there, my sand there. Okay, so the sources first. Let's just grab our snow source and put it into here, and our snow source, sand source, and put it into there. Then we're going to get our simulation, our solver settings going into the simulation settings there. I'm just going to leave this here like this for now. So we're going to be emitting from a sphere. We're going to emit snow from this sphere, and we're going to emit sand from this sphere. So the other thing I did, which we'll just attack early on. Oh, let's get a collider going. Yeah, let's drag this into the collisions there. Yeah, the other thing that actually, do I want? Let's just drag this open here a minute. Simulate NPM. I think I want to get an actual collider node in here actually first. Yes, let's undo that, pull that over there, and let's stick the collider in. The collisions and the mesh into the geometry of that collider. So now we can adjust the detail size of that collider, basically meaning whether the particle is going to fall through it or not. So the detail size is about here. I'm just going to stick that down to about I'll tell you what, we'll leave it at 5 for now, because we might just get some sort of better speed on this tutorial rather than cranking all our sizes down, but we'll just make a note that we need to change that in a little while. Right, so there we go. Torus is in there. So if we just put out these granular particles into the output, for now, just press Control plus period or full stop dot, whatever you want to call it, in whatever language or part of the world you're in, and then we can see that we can just play this for now, and these guys are just going to drop down, really boring. And they're going to fall through the torus because, let's just get this back here again. What have we got going on here? There's our collider, the torus, we've got the sand going through there and there. We've got the NPM solver settings on. What did I do in the collider? Let's just Control plus period. Let's change that to a shell. I'm going to change this to absolute. I will maybe bring the detail size down. Let's just see if that changes anything. Just going to Control plus dot. Pull this out of the way. Let it just generate for a second. Let's rewind and play. And it's still falling through the torus. That is interesting. Real world problem right in front of your eyes. So let's have a look at what's going on. Solver settings, simulate NPM into the output, granular, sources, collider, I've got the collisions here, this is the torus shape, this is the collider going into colliders, offset inherent orders, start frame, use end frame is off, am I starting from frame 1? Yep. Method is automatic, don't need, automatic is fine, absolute, we don't even need it absolute, we can stick it to relative, but it's as was. Friction, roughness, inherent velocity, offset 0. So, what is going wrong here? I've got a feeling, woo, if we go back to, actually let's just open this up, I'm just going to pause the graph again. If we go back and extrude this a little bit. And then I'm going to go back to Bifrost, and I'm going to undo this. Let's rewind and play that now. There we go. So you need an extrusion on your object. I thought I just had a brain fart and didn't remember that. Okay. So that is working. Let's pause the graph again. Right, so the next thing I want to do is do something a little bit interesting with the two sources themselves. We don't just want to, if we look back at the example, this is emitting quite vigorously with some anger and hatred. And we want to do the same. So I'm going to set an initial speed of 3 in here. And we want these things to be slightly different. So I'm going to stick 5 in here. Volume preservation, I want to sort of bring it down a bit. I don't want them all sticking together, so I'm going to go 0.1. Viscosity, the mass density, that's how heavy it is. I'm going to stick that at 100. That's for the sand. We've got an end frame set to 1, which we don't want, so I'm going to set that end frame to 100. I'm going to go back to the snow. I'm going to do the same thing. I'm going to set that to 100. And the mass density, go slightly different. Let's go 150. Volume preservation, I'm going to bring that down because we want it to move around quite a bit more. friction, cohesion, initial firmness. No, I'm just going to leave that hardening. Hardening, let's just go like 0.5. Initial speed, done it already. And inherent velocity, I'm going to stick at 5. And I'm going to do that with the sand as well. You can do whatever you want with these settings, guys. This is just me doing what I want to do. Right, so the next thing I want to do is give it some kind of animated emission or animated direction. So I'm going to open up the sand properties, and down here we can see we've got a bunch of ports that we can plug stuff into. I'm going to use some turbulence. I'm going to use a fractal turbulence. All right. Fractal turbulence is going to need some animation to it, so we're going to have to attach some time to it. So I'm just going to stick in here time, and I'm going to drag out frame to what am I going to drag it out to? Time. So frame to time, and then we're going to take our noise into direction. Now in the fractal turbulence itself, we can add some magnitude. So let's just go like, I don't know, 10, frequency of 1. Number of frequencies, let's have 3 in there, and a ratio of 0.5 and a frequency ratio of 0.4. These are, believe it or not, random numbers. So we're going to look at the sand now and just see how that's behaving. Let's just drag this out of the way, let this compile, drag it out of the way, and just going to rewind and play. So we can see this one is going absolutely crazy already, shooting all the way around there, and it's filling up the torus pretty fast. Kind of want that. I mean, but we'll see. We could play with it in a little bit. We're probably going to bring the particle size down somewhat, and I'm just going to go in here and change the type of particle we're looking at. So let's go from disk in the solver settings to, let's go with spheres, because I just like how spheres look instead. That's sand. I can't remember which one is which actually. So over this side, I thought it might be that sand. Initial speed of 5 might be a bit much, but let's leave it at that for now. I want to change the size of the different particles. So we're going to go the particle display scale of the snow. I might leave that as is, and the display scale of these particles I might go over like 0.7, make them a bit smaller. Now, particles per voxel default is set to 8. I'm going to put that up to 12 because we want more particles per voxel. It's not for free, but I think it's going to help with the amount of particles we can start throwing into the torus. Again with the snow, I'm going to do the same with the voxels there. That's 12 particles per voxel. You think about a voxel, that sort of cube that you have in your mind, lots of little cubes all strung together, making a grid, a voxel. Then you will sort of understand. It's kind of like how my fluids works a little bit, but not quite. Right, so we've got our fractal turbulence going into the direction. I'm just going to grab this and a time. I'm going to Control C, Control V, and I'm going to drag these over here, and I'm just going to drop down the snow properties, and I'm going to drag the direction into there as well. Okay, so if we want to smarten it up a bit, we can just drag over all of them and hit L, and then it sort of smartens it up, and we can see things a little bit better. So we've got some animation going on with fractal turbulence set on the direction. Let's just unpause the graph, let it compile for a second, and we'll jump back into the Miocene, and I'm just going to hide these two guys so that we can see that these are now spheres and it's looking a little bit more interesting. Let's hide these two guys, and let's just do a quick play. So you can see these guys go really fast, these guys are going slow, which is nice because we've got two different attributes combining and colliding against each other. And you can start to see how you can get some interesting effects going on. This is a big slow blobby mass, and then we've got these kind of faster and harder sand particles coming around, and they're all mixing and doing something interesting to look at. If they all had the same attributes, it would just be, you know, like a standard kind of mix. But this is blobbing around, and well, for me, I'm enjoying that. Call me weird. Right, so let's rewind. Now the next step, and you won't believe how fast I'm flying through this, and the past couple of days I've had trying to figure certain things out. What I wanted to show you is two sources that are both sand, and that has been the problem when we come further down the line and we're trying to assign colours. There are now ways that I've seen other people show in the Bifrost forums of how to do this, but as it stands, it's a bit complicated, and I didn't really want to show you guys that at the moment and frighten you off. I want to try and keep this nice and simple. We've just got a few nodes, and we'll just get some colours, different colours coming out of both of them, and then maybe later on we'll jump back in and show you how to do two of the same sources. So, I mean, the snow, you can sort of wind down and make it a little bit more sandy anyway by changing a lot of these attributes. And again, with the sand, you can make it more snow-like or thicker and blobbier. But for now, it's just easier to have two different types of sources, because just very simply, they've both got different IDs. Whereas two sands have the same ID, but there is a way of telling Arnold to create different IDs, but I'm not going to go into it. I'm just not going to bore you with it. Okay, so the next thing we need to do is create a new node. Oops, let's just pause the graph again. Is to create a new node called split points by material. So just start typing in split here, and then we can open up split points by material. I should say while I'm here, I'm running Maya 2020.2 with obviously the version of Bifrost that comes with that. This is not the beta version of Bifrost. And the Arnold version that comes with 2020.2 as well. So with this, we're going to take our granular particles and we're going to put them through the points. And this is where Bifrost enables us to understand that we've got two different sources, these guys, and how we can assign different shaders to them. So next step, why not just do this quickly? If we just open up the upper shade, I'm just going to create two Arnold standard surface shaders. I'm going to make one A color. Let's just go with that, and I'm going to make another. Oh no, let's just go with red. So we're going to drag those two bad boys into the graph. So let's do that now. Middle mouse, drag into the graph. It's happening off screen for me, but you know, don't worry about it. You'll see them in there in a second. Here we go. Let's kill that. Bring this back here. So we've got two materials, and now we need to create an assign material. And let's just Control C, Control V that. So we've got two of them. So I'm going to get this material is going to go into the surface material, and this material is going to go into the surface material, and then we're going to pull out our sand particles into the bottom one, so into the geometry here, and we're going to pull out the snow particles into the geometry here. So now what we've got is everything working as it should, but here's the last kind of, well, it's not tricky, but it's just a part that you've just got to remember. We've got two ports coming out here, but we don't want to put them into two ports on the output. I just want to feed them into one port. So the simplest thing you can do here is create an array. Don't be scared by an array. It is literally just somewhere that stores data. So let's just put our first array into that port, and then our second one into the array into that port. So it stores data. It's taking this data and putting it in here and storing it, and it's taking this data and putting it here and storing it. And what we can do from here, because and only because we've got a split point material node here, we can take this information and plonk it straight into there, and it has got that information that there are two sources with two assigned materials, and they're coming into the output. So hopefully, if I just go Control plus full stop, period, whatever you want to call it, and we'll drag this back down. Well, there you go, proof's in the pudding. We have got two colours, we've got two different types of NPM material, and I can hit play, and these guys will collide with each other. You can see the collisions happening here. That is all great. That is me done. There's, unfortunately, we just don't have the information out there at the moment, so you really have to knuckle down. I've been through a lot of Bifrost nodes on the Autodesk website, looking up different nodes, what could work, what couldn't work, asking people. People would send me on the path on the Bifrost beta forum, things they thought might work, but I mean, they did work, but they were too complicated for you guys. I'm just trying to keep it a little bit more artist friendly, and that is an artist friendly, as far as Bifrost goes, an artist friendly graph. That is, nice and simple, really. There's just a few nodes there, and it makes sense. It's simple, and so you can go off and play around with this, make your own one, refer back to this, and let's just check that it renders in Arnold. So we'll just go Arnold lights, and we'll just stick a sky dome in there for now, and I'll put a floor in. And what have I done here? Where are we going with that? I just want to go 9 degrees and just put it down to there for now. And let's just give Arnold, what I'm going to do is just get the Arnold render window in. Hello Arnold. Okay, and we'll just press play there. And hopefully Arnold will render that. So, obviously, over the years we see lots of different plugins and stuff for lots of different bits of software. Never really Maya, where they're mixing loads of particles and you're getting, different colours mixing and that kind of thing. So for us, this is a bit of a first. We're probably a bit late to the table on this. There we go, it's working. I do have some kind of weird shader on the Taurus, but you just forgive me for that and create your own. But it works, and there we go. That is my information to you guys. And yeah, go forth and multiply. I'll just get that graph up again so you can have a look. And I will do another tutorial where it's slightly more complicated, where we can use the same sources. But I mean, don't just think that you can just use one sand and one snow. Oh no, you can create more of these, and obviously it doesn't have to be in a torus. You can create, the standard fish tank type simulation that you would see, where you get lots of different particles coming in and mixing around. I mean, you can create some seriously awesome stuff on this, and the simulation times are 100% faster than any kind of Nparticle or particle within Maya. So yeah, just have a look at that graph. Come back to this video as many times as you want, obviously, and I'll see you guys on the next one. Have a good weekend, stay safe, and take care. Cheers, guys. Goodbye.